Welcome everybody. This is lesson 2.2, which is going to be about while loops, which is our next programming control structure that we'll have to work with. After if and else, the next logical thing to do is talk about while loops. So oftentimes it's useful to repeat code, which is to say to not just run the code once through, but have it continue to do the same code over and over again until some condition has been met. So for example, if you want to see if a number is prime, then one algorithm or one way of doing this is to check all the numbers that are less than or equal to its square root, and if any of those numbers divide it, it's not prime, but if none of them divide it, then it is. Remember that a number is prime if the only numbers that divide it are 1 in itself. So I'll just list a couple of prime numbers up here. 2 is prime, 3 is prime, 5 is prime, 7 is the next prime number. 9 is not because 3 divides it. No other even number besides 2 is prime. 2 is the only even prime number. What's the next one? It would be 11. 11 is prime. 13 is prime, and so forth. So if you want to check if any number is prime, so say I plug in the number 97, and you're like, that's tricky. How do I know if it's prime or not? Well, test 2, test 3, test 4, test 5, test 6, test 7, test 8, test 9. If 9 doesn't divide it, then you can stop right then and there, because 10, if 10 divided it, then it would be 10 times something that's smaller than it, because 10 squared is 100, and 97 is less than that. So anyway, you only need to check so far. You don't need to go all the way up to the number. You can stop when you hit the number's square root, which 97 square root is 9 point something. So here are some examples. Is 27 prime? Well, you ask, well, does 2 divide 27? Why not check if 1 divides 27? Well, 1 always divides any number, so we wouldn't check that one. So 2 doesn't divide 27, it's not even. Does 3 divide 27? Yes, 27 divided by 3 is 9, there's no remainder, so 27 is not prime. Is 29 prime? Well, we're going to check all the numbers that are less than or equal to the square root of 29, which is about 5.39. So I forgot to put that for the other one. The square root of 27 is probably 5 point something. So we'd check up to 5 and then stop. So does 2 divide 29? No, it doesn't. It's not even. Does 3 divide 29? No, because the next multiple of 3 is 30. 29 is, 27 divides, is divisible by 3. 30 is divisible by 3. 29 is not. 4, does that divide 29? No. Well, if 2 divided it, 4, that would be the only way 4 could, so it doesn't. Multiples of 4 are even as well. Does 5 divide it? No, it doesn't end in 5 or 0. So none of those numbers divide 29, so it must be prime. Again, I'll let you guys think about why can we just stop when we hit 5? Why do we not need to go to 6, 7, 8, and so forth? And I'll let you guys think about that mathematically, why that's the case. We can stop there. So, all right, so we're repeating tests here, right? We're testing a bunch of numbers, and in fact, there's no way for us to really write this without doing some kind of loop, without continuing to have our program run the same code, namely check if this number divides our number that we're interested in. And so how would we do this? Well, we're going to do this there's several ways to do it, and the first loop structure we're going to show you is called the while loop. After this unit's over, we'll talk about another loop structure called the for loop, which is a little more syntactically complex. There's more going on in the syntax of it, but it is, I guess, a simpler loop in some ways than a while loop. I don't know. I find while loops to be just a little bit easier to understand than a for loop. So while loop is used for repeating code blocks or the loop body while the test is true. So it looks a lot like the if code, except instead of writing if test, we write while test. And so what this means is while test is true, repeat the loop. So we'll just keep doing the code that's in the curly braces as long as the test is true. And then once the test is false, we will exit the curly braces and continue on with the program. So that statement, I'm executed when test is false, will run as soon as the test fails. So this is a flow chart for how it looks. You start up at the top, right? And then you make a test. In some cases, you just don't even run the code in the loop. If the test fails right away, then you just head on down and skip anything that's in the loop's curly braces. But if the test is true, then you're going to go into the while loop and then make another check on the test. And if the test is still true, you'll go into the while loop, make another test. If it's still true, you'll go into the while loop, make another test. And then if the test finally fails at some point, that's when you finally exit and continue on your merry way. So you can imagine you might have some problems arise where that test just never fails and you just keep going around stuck in this loop forever and ever and ever. And that's called an infinite loop, and it's a programming error. You don't want your programs to ever have infinite loops, but if it happens, it's okay. Just try to analyze why did this program get caught in an infinite loop and fix it. So we'll talk about what are some common ways that programmers get caught in infinite loops and how to avoid that. So, all right. So let's write some pseudocode for that last example that we had of determining prime numbers. Is this number prime or not? So pseudocode is a code-like instruction. So you're writing out in plain English or some other language if that's your preferred language. You're writing instructions that are formatted like code. So you're going to maybe use curly braces. You'll kind of write little method headers and stuff like that. But it's not actually in any particular programming language. And it's really helpful for breaking down problems into easier chunks and trying to like analyze what what is this algorithm. And you don't need to have a programming language to write pseudocode. You can write it in anything and then figure out how you could write it in Java or in C++ or some other language. So if you ever go onto Wikipedia oftentimes and look up an algorithm for doing something, they'll give it to you in pseudocode, and then you have to take that code and implement it in an actual programming language. So here's our pseudocode for is a number prime. So is number prime is our question. So we got to check all the numbers that are less than the square root of num. So for example, does 2 divide num? No. Does 3 divide num? Etc. 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 And then if none of them divide it, then num is prime. So that's not quite pseudocode. Let's actually try. This is just what our algorithm was from earlier. Let's try to turn this into code-like language over here. So first we've got Boolean is prime. So we're returning a true or false statement, and we're taking a number in as a parameter. So this is already looking very Java-y. So this is kind of Java-like. But then the rest of this is not, right? Set test to 2, right? That's not a Java, you can't write that. While test is less than or equal to square root of num, that looks kind of like Java again with the curly braces. Return false, return true, this looks kind of like it. But let's just follow along what this is doing. So the first thing is we're starting our test number. Test number is going to be 2 because that's our first number we're checking over here. Note that all of this right here, this is our loop. We're looping here, continuing to do the same check, which is, does this divide num? Does this number divide num? Does this other number divide num? And what we're doing each time is we're just incrementing this number 2 to 3 to 4 to 5 and so forth, right? That number is going up each time by 1. So the while loop is going to run as long as test, this number we're trying to divide num by, is smaller than or equal to the square root of num, right? So we actually needed to get to the square root of num because when you're testing a number like 121, for example, you know this is 11 times 11. And so you're not going to find out 121 is not prime until you test 11 exactly, because all the other numbers don't get you there. So you would need to test the square root exactly, which is why this goes until it's less than or equal to the square root of it. And then we check if the test divides num, we're done, and we're going to return false. So this is not prime, because one of our tests divides the number. And then what we do is we make the test number go up by 1. So we increment test. Increment means increase by 1. Increase by 1. And so we make our we increment by 1, and then we just keep looping. We keep testing until the test is equal to square root of num. We do one final test. We increment test to 1 more than the square root of num, and then we stop because the test fails. And if the test has failed at that point, we know we're prime. So we know we're prime because all of our test numbers did not divide num at any point. And so that would be our prime program. So let's go ahead and look at the actual code version of it. So we're going to kind of convert it line by line. Boolean is prime int num. So it looks almost identical. We just didn't have the public static part. So public static Boolean is prime int num. And then set test to 2. Well, what is that? That's just creating a variable called test, setting it equal to 2. So int test equals 2. And then while test is smaller than or equal to, is what that should be, square root of num. While test is less than or equal to math.square root of num, so very similar looking. We've got parentheses though around our test, like so. And then if test divides num, that's just if the remainder is 0 after doing division. So if num mod test equals 0 is how you would do this. And then we return false, boom. So, oops, I forgot my semicolon. There's the semicolon. And then we increment test. We go to the next number. And that just looks like test plus plus. That says add 1 to test and resave it. So test goes up by 1. There's our curly brace. And then we return true if none of the test numbers divide num. And that's turning our pseudocode into an actual Java. And in this case, our pseudocode is very, very close to the actual thing. It's almost identical. This isn't always the case. It just depends sometimes how detailed you're going to write your pseudocode. You can oftentimes get away with writing pretty, I want to call it vague, but not super detailed pseudocode and then converting it. And then you've got more work to do to break it down into smaller actual programming language chunks. But in this case, it pretty much went line for line from the pseudocode to the actual code. So that's how you would check if a number is prime. You loop testing, keep testing the next number, and then when if none of those numbers divided the number of interest, then you know it's a prime number and you can return true. Okay, so here's some common while loop errors. If you forget to update the variables that the test refers to in the loop body, you're going to get an infinite loop, because that loop test, that test inside the parentheses, eventually needs to fail. Otherwise, you're stuck forever running the same chunk of code over and over again. So here's an example. So say we ask the user to enter a number. We get that number from scanner using input.nextInt. While the number is more than 0, we want to print out half of the number. So this is attempting to kind of print the number, divide it by 2, print the number again, divide it by 2, print the number again, divide it by 2. So it should give you something like, 8, 4, 2, 1, and then 0 would be the last one. However, what you might see is that number doesn't get changed here. So right here, number never changes, isn't updated. And since number is not updated, we just keep printing half of whatever number is, and number stays the same the whole time, and so this will never end. This loop will continue going forever. And so if they were to, say they enter in 8, so if they enter in 8, then this is going to print 4, 4, 4, 4, 4, and the program won't ever stop. And so you have to manually stop it, otherwise your program will be stuck running this for, until it runs out of batteries. Or the computer breaks. So to fix this, you would have to add in a line somewhere in here, number divide equals 2. And if you did that, then you would reassign number to half of whatever it is, and then it would eventually hit 0 and stop. Here's another common while loop error. Your variable never fails the test. So for example, say we have, this isn't printing anything, but say we start our variable at 1 and then we loop while it's more than 0. Each time we add, so we're going to add 1 to the number. Now this actually will stop eventually, but it doesn't stop until it hits about 2 billion and something. And at that point, it hits what's called an overflow error, where once you get to the largest integer that a computer can, that Java can store, once you hit the largest int, then it wraps back to negative the smallest int you can possibly be. So then it's less than 0. But this test really isn't working the way you want it to, because the first time num is 1, and we check 1 is more than 0, true, so then we increment it, so it becomes 2. 2 is more than 0, and that's true, and we increment it. 3 is more than 0, so it's true, we increment it. 4 is more than 0, that's true, and so this just keeps going and going and going. The number is never getting closer to that test. So this wouldn't be a very good while loop, because it's basically an infinite loop. Alright, let's do a program together where we kind of tie in some of these loop concepts. We're going to write a program that prompts the user for a positive number, and then prints out all of that number's divisors. So everything that divides the number. So like, for example, 10 is divisible by 1, 2, 5, and 10. So you would print out all those numbers. 24 is divisible by 1, 2, 3, 4, 1, 2, 3, 4, 6, 8, 12, and 24. So it has a lot of divisors. So here's some sample runs. Run 1. We're going to ask the user to enter a positive number. Say they type 10 in. Then we'd print out divisors of 10, 1, 2, 5, and 10. So looks like we've got a loop going on right here. So here's our loop. Loop while loop here. Because we don't know how many divisors we're going to have to print out, and we've got to check a bunch of numbers, see which ones do in fact divide the number in question, 10, and which ones don't. So here's another run. What happens if the user types in a negative number or something not positive? Well, we should probably check to see what their number is and say, hey, that's not a valid number. -1's not positive. Please enter a positive number again. So we've got another while loop here. So we've got a while loop here as well. So we're going to loop until they give us a valid number. This is called input validation. This is input validation. We're making sure that whatever they type is something that we want them to type. And so if they enter a negative number, we ask them again to prompt. If they enter another negative number, we'll ask them again to prompt, and so forth. So they can get themselves caught in their own infinite loop if they're really stubborn and never type a positive number into the computer. But if they enter it, when they finally give up and they're like, all right, I'm tired of this, I'll put a positive number in, we print out the divisors of that number, which 5 only has 1 and 5 as divisors. Okay, so let's, I'm going to fire up IntelliJ, and you should do so as well, and let's go ahead and write this program together. Okay, so I got IntelliJ kind of started here. I have a divisors class. I've got a scanner already declared, and I already broke off a method for the printing divisors part, because there's even though it's just one line, even though it's just this one line here, there's a lot happening behind the scenes. There's a lot of code to get that one line to work. So I'm going to put that in its own method, and I called it print divisors, and it needs to know a number in order to print the divisors of. So we can either handle the input part first or the printing divisors first. I think the input part's probably the easiest one, so let's go ahead and do that first. So we need to get a number from the user, so the first thing we need to do is ask for a number. Please enter a positive number. And I made it a print statement so that the input happens on the same line. So let's go ahead and save save their input into a variable, input dot next int. So int number equals input dot next int. So at this point, I've got a number, and I don't know if it's a positive number or a negative number. And so I should check to see if this number is positive or negative. And if the number, basically while this number is invalid, while the number is not positive, means 0 or negative, I need to ask again. So let's go ahead and throw this into a while loop. While number is less than or equal to 0, so these are invalid numbers, what do we want to do? We want to tell them, hey, that's not a positive number. And I think it was number is not positive, right? So we're telling them their number is not positive. And then what do we need to do? Prompt again and re-update number. So these two lines of code are going to get repeated, and oops, it doesn't like this. Why do you think this is all red squiggly right here? If we mouse over it, it says variable number is already defined in the scope. And the problem is we're trying to redeclare int right now, or redeclare number as another int, but we know what number is already from this line. And so we can just leave number like that, and that will reassign it. And when we're done with this loop, when we're here, we're guaranteed, see if I can spell that right, that number is greater than 0, because if it wasn't, we'd still be in that loop. We'd be in that loop as long as number is less than or equal to 0. And so when we're here, we're guaranteed to know that number is a positive number. Okay, so that's how the while loop works for input validation. We can go ahead and see that it's working properly by just printing out what number is. Number is, and running the program at this point, and it should just keep prompting the user until they type in something that is positive. So let's go ahead and try to break it. -5. -5 is not positive. -10 is -10 is not positive. -1 is not positive. 0 is not positive. 5, number is 5. Okay, so we exit the loop when we type in 5, and so we know we're out of the loop when that number is a positive number. Okay, so that's our input validation. We get the number from the user. So here's getting the number from the user. Get the first number from the user. While the number is invalid. So while the input is invalid, we're going to go ahead and loop. So tell them what they did wrong right here. It's not a positive number. Reprompt on the next line. Ask them again. And then the next line is to update the input variable. So you update the input variable, because if we don't have this, then we're never going to leave the loop. It will just keep printing out number as positive. We can just see that in action here for funsies, because infinite loops are kind of fun. So let's go ahead and run this program now without the prompt and see what happens when we enter in a negative number, a -1. And whoa, it's going forever. It's just printing -1 is not positive. It's an infinite loop. Super scary. Press the little red square and then it will stop, so don't worry. Okay, so let's go ahead and put those back in there. Alright, so now we'll do the print divisors method. So print divisors is going to print all the numbers that divide it, and we're going to start our numbers off with 1, because 1 divides every number. So we're going to start our numbers with, we'll call them divisors. Divisor equals 1. We're going to start it off at 1, and we're going to keep printing divisors as long as it's less than our number in question. Because once we get to the number, then we're done printing divisors. So how would this look like? Well, we're going to print out the divisor if it does in fact divide num. So if num mod divisor equals 0, then we're going to print out system.out.print that number, divisor, and then a comma with a space afterwards. I think I need to print something else out. Let me just say, oh yeah, I need to print out divisors of 5, colon. So let's write that at the beginning. System.out.print divisors of num, colon. All right. So let's go ahead and then print out. So next what we need to do is print out the number itself and num. And the reason why we need to print out the number itself at the end is because that's the last thing. We're doing all the numbers less than num, and then our very last divisor is the number itself. And so we'd print that one out at the end. Okay, let's go ahead and call print divisors. Print divisors, and the number we're passing it is number from input. See what happens. So we'll go ahead and enter a positive number. Let's just remember, yep, -1 still doesn't work. 10. Oh, whoa, that's a lot of ones. Okay, what went wrong here? Let's go ahead and stop it again. So I think we got ourselves into an infinite loop in print divisors somewhere. Let's just trace the code. So we start our divisor at 1 while it's less than num. If it divides it, then we print out the divisor and a comma. And then, oops, I forgot to do something. Let's see if you guys can see what I forgot to do. I forgot to update divisor, right? Divisor is stuck at 1 right now. It's not changing at all. So what do I need to do? Well, I need to make divisor go up to the next number. So, and the easiest way to do that is to say divisor plus plus. So this says increment divisor by 1, so it goes up to the next number, because we're going to test 1 and then 2 and then 3 and then 4 and so forth. Okay, so hopefully that fixed my infinite loop, and let's see if our program is working now. Enter a positive number, 5, divisors of 5, 1 and 5. Nice. Let's try another number, 24, divisors of 24, 1, 2, 3, 4, 6, 8, 12, and 24. Fantastic, we got print divisors working. Okay, so you can test yourself with some practice of problems with while loops, and I'll have a mini lab for us to dive into starting on Monday next week. Enjoy your weekend, and maybe I think next week I'll be able to involve some furry friends in the videos if I can get on recording at home, and possibly also a drum solo. We'll see. But anyway, have a good weekend, and I'll see you on Monday.